Hello students. So in this part of chapter electricity, we will discuss about the advantage and disadvantage of series and parallel circuit for domestic wiring. In the previous part, we had discussed about how the resistors are connected in series and parallel. Now we are going to see their advantage and disadvantage. So the first topic is what are the disadvantages of series circuit for domestic wiring. Okay. So the first point is uh, it stops if any one electrical appliance stops working, then the all other appliances will stop working because there is only a single path for the current to flow. Okay, if an appliance has stopped working, means the circuit will become open. So this is the first disadvantage. Second is we have only one switch uh, for turning on or off the whole all the appliances. For example, the lights which are usually used for decorations in Diwali or other festivals. In those lights, there are around 40 to 50 bulbs that are connected in series, which can be switched on or off by a single switch. They cannot be turned on or off separately. Next is the appliances do not get same voltage so that as that of the power supply line. Means we have seen that in series circuit, the total voltage applied by the battery was being divided like V1, V2, V3. So of course the voltage the voltage received by each appliances would be less than the total voltage, so they cannot glow up to their full extent. And the fourth reason is the overall resistance in a circuit increases too much, due to which the current from the power supply is low. Okay, we know that the formula of R is V equals to R equals to V by I. Okay, it from here we can see that the resistance and the current are inversely proportional, and we also know that in series circuit the overall resistance increases, so more would be the resistance, less would be the current. So this is one more disadvantage, that a very less currents usually flows through the circuit, so each and every appliance doesn't get enough current to glow properly or work properly. Now let's discuss the advantage of parallel circuits in domestic wiring. Usually in our home, all the electrical appliances like fan, bulb, TV, all are connected in parallel. Let's discuss the advantage. The first one is if electrical appliances stops working, if any one electrical appliance stops working, then it doesn't affect the other appliances. Suppose a bulb, if a fan stops working or a bulb gets fused, then it doesn't affect the TV or some other appliances. Okay, we can even run the TV if some other appliances is not working. So this is one of the advantage. Next is we have a separate switch for each and every appliance. It doesn't means we can, if we want to turn off the fan, we can switch off fan and we can keep the bulbs on, and similarly we can separately keep on and off different electrical appliances, which was not in case of series connection. So, and the third one is as they all get same voltage as of the power supply lines. Means if we are getting 220 volt from the power supply line, so each and everything, whether it is bulb, whether it is TV, whether it is fan, every appliances will get the same voltage, because we have seen that in parallel connection of resistors, all the resistors were getting the same voltage. So if they're getting same voltage, they can uh, work properly. Then the fourth point is the overall resistance is reduced. Okay, and hence the current which flows through the circuit is enough. It's high here. Saying high means it is enough, means it is sufficient. Okay, we have seen that in when the resistors are connected in parallel, the overall resistance reduces. Okay, so the resistance of the whole circuit reduces, so enough current can flow through the given circuit. So that is why parallel circuits are uh, usually used for connections of different electrical appliances in our homes. Now let us discuss power. Okay, you might have seen that on different electrical appliances, the ratings are the ratings are written that, for example, on tube lights it is written 40 watt. For example, the LED bulbs it is written 12 watt, 15 watt, 20 watt, okay, 5 watt, 10 watt. So what are these watts? These are actually they are mentioning the electrical power that an appliance will consume. Okay, now let us see the definition. It is defined as the rate of doing work, means here rate of doing work means how much energy it is consuming or how much work that appliance is doing, because it will work only when it will consume the electrical energy. So it can be written numerically as mathematically it can be written as P equals to W by T. Here W is the amount of work done and T is the time it takes, or in how much time how much energy it is consuming or how much work it is doing. So this is the formula of electric power. Let us see the units of power. The units of power is watt, and from this formula, from the same formula, we can see that if suppose uh, work, yeah, work is also measured in joule. Okay, so if the work is done, if the work done is 1 joule and the time taken is 1 second, then we will say that the power consumed is 1 watt. Okay, now 1 watt is a very smaller unit of power, and usually we are using the electrical appliances of higher power, and even we are using energy in more quantity, so a bigger units are used. Here it is given kilowatt, one is megawatt. Okay, even higher than kilowatt. 1 kilowatt is equals to 10 raised to 3 watts. Similarly, 1 megawatt is equals to 10 raised to 6 watt. Okay, so this was about the units of power and the definition of power. So apart from P equals W by T, there are few more formulas to find the power consumed by an electrical appliances. Here, let's see. There is one more definition of power. It's given that electrical power is the rate at which electrical energy is consumed. Okay, just now we discussed earlier. It was given that the work done in unit time. So either it is doing work or it is consuming electrical energy. Both are here almost similar, because it will do work only when it will consume the electrical energy. So the formula is going to be same, P equals to W by T. Now to derive the other formula, we have to substitute few values of W here. Now we know that from the formula of electrical potential, that V was equals to W by Q. V was equals to W by Q. Okay, this formula can be written as W equals to V into Q. Okay, and now this Q can be replaced by I into T from the formula of current, that is Q equals to IT. Okay, so now the W is equals to V into I into T. Now substituting these values in equation 1, we are going to substitute these values in equation 1. So here it is done. V into I into T, this T and this T will get cancelled. So the left out part is P equals to V into I. So this is an important formula that will be used in numericals. Okay, so this is one of the formula to find the power. Now let's see what does this formula means. It means that the power used in heating a resistor or turning a motor means the appliances which we are using. So the working of that appliances or the power used by those appliances, it depends on two things. One is the potential difference, that is V, and second is the electric current passing through it, that is I. Okay, if we know the voltage and the current for a given appliances, we can calculate its power, how much power it is consuming. Okay, so for this formula it can be written as if suppose for a given appliances the applied voltage is 1 volt, and for that voltage the current flowing through it is 1 ampere. So we can say that the power rating of that appliance is 1 watt. It is 1 watt. Okay, so it can be written as 1 watt is the power consumed by an appliances when it is operated at potential difference of 1 volt and it carries a current of 1 ampere. Okay, so this was the meaning of this formula. So our second formula is P equals to V into I. There are a few more formulas uh, which can be derived from the using the same formula, that is P equals to V into I. Okay, we know the Ohm's law, that is V by I equals to R. From this it can be written as V equals to IR, means this V by I equals to R can be written as V equals to IR. Now on substituting this value, on substituting this formula in this equation, that is the first equation, P equals to V into I. So V will be replaced by V will be replaced by IR. So I into R, and there is one more I. So there would become there would be 2I. So it can be written as I square. It can be written as I square. So the overall formula becomes P equals to I square, where I is current and R is resistance. So if we know the value of resistance and the current, then we have to use this formula to find the power of an electrical appliances. Okay, similarly there is one more formula. Again we will start with the same using the same formula, that is P equals to V into I. Okay, now here again we will be using the Ohm's law, but instead of substituting V, we will substitute I. Now from Ohm's law, I can be written as V upon R. I can be written as V upon R. So when we will substitute the value of I as V by R, there would become 2V in numerator. So V into V will become V square, and R is in denominator. So our formula becomes this: P equals to V square by R. Okay, so this is the fourth formula for finding the power if the voltage, the applied voltage and the resistance is provided. Okay, so you will be using all these four formulas for solving the numericals. Here you have few questions to solve. Just solve it, and tomorrow we will get the answer.